I'm Lloyd.
I'm Lloyd.
And today we're going to give you our technical service bulletin on Holley/Ford 94 carburetors. Holley 94s were used by Ford from 1938 until 1957. There were at least 17 versions of the Holley 94 produced. Henry Ford wanted a better carburetor design to replace the Stromberg 97, and in 1938 he found it. The Chandler Groves Company was enlisted to build an entirely new carburetor to replace the Stromberg 97. Chandler Groves was contracted to manufacture the carburetors for a one-year production run. In exchange, Ford was granted the rights to the carburetor itself. After the one-year run with Chandler Groves, Holley was hired to build the carburetors with only minor design changes until the production run ended in 1957. The Holley 94s and Stromberg 97s look similar, but there are some key differences setting the two designs apart. The fuel inlet is on the top of the float bowl on a 94 as opposed to the side of the bowl on a 97. The 94s also use a center-hung float, which is less likely to cause fuel starvation issues when cornering as compared to the 97s, which utilize a side-hung float. The 94s also used spray bars, sometimes referred to as aspirator nozzles, to discharge fuel as opposed to the 97s, which use an emulsion tube design. So the first order of business is to take these 5 screws off and remove the upper half of the carburetor from the float bowl. Be careful when you pull this off to not bend the tang, which is here. This is what determines your float level in terms of rise and drop. And you'll need to check with what vehicle you have that you're working on and what the specifications are for it, because they produced a lot of these Holley 94s and use them on a lot of different vehicles. So in order to remove this pin right here will slide out. Slide the pin out, set it aside, take your float off, remove this, and that's pretty much all that there is on the upper half of the carburetor. Next, we get into the main part of the carburetor. We'll go ahead and pull this gasket off, set it aside. So the first thing we're going to take out here is the aspirator nozzles, which is both of these. There's 4 screws, flatheads, 1, 2, 3, 4. And this carburetor may end up being a little bit different than whatever 94 you may be working on. We've got several of them here, and they're all a little bit different, but the principles should apply across the board. These are different lengths too. There's taller screws back here and shorter screws up front. Next, we're going to take out the jets, which are here and here. In order to get them out, we have to remove these plugs first. An important thing to note whenever you're removing the jets, take the time to select a screwdriver that fits the jets as snugly as possible. Because if you use one that's close, but it's not technically the right size, then you could end up breaking part of the jet head off. They're made of a soft material, presumably brass, and then you're going to have a lot of fun trying to get it out. Got our jets out, we'll set them aside.
We just went through this carburetor recently, so we're just going to show a teardown and a reassembly, and we'll point out some areas to look out for whenever you're trying to recondition one of these. So the next thing we're going to take out is the accelerator pump, which is done by compressing this spring and then sliding the tab that is the accelerator pump back. This can be a little bit of a trick sometimes. You kind of have to just be patient with it. Be careful not to let the spring pressure go all at once, because if you do, the spring will shoot off and you will lose this upper flat piece. So we'll set this aside. And then our accelerator pump comes out of the accelerator pump well. This one is a leather accelerator pump. It's a little bit bent. And there's a lot of conjecture that a leather accelerator pump is preferred. In our experience, as long as it seals in the accelerator pump well, that's all that matters. And the blue, some type of plastic, not sure what kind of plastic it is, but the modern replacement for this is not leather. It's blue and it's some type of plastic. In our experience, the modern plastic ones are superior, which is contrary to a lot of what you will read on the internet and hear from a lot of people. The main thing is, whatever material you go with, just make sure that it has a nice snug feel when you get about halfway or a little farther down the accelerator pump well. See, I can drop it in on the top, there's nothing, and then right about there's resistance, and I have to push down on it in order to make it go down, which is good. You want a resistance whenever you are selecting an accelerator pump. So we'll pull this out and set it aside. The next thing to remove is the accelerator pump discharge nozzles, which is this piece here, which will come right out because we already took off the flat retainer plate and screws that hold it down. So we'll pull it out, and then we'll turn the carburetor body upside down and drop the valve out that is immediately underneath that, which is this right here. The pointy end goes in first. Remember that for later. There are 4 gaskets here. 1, 2, 3, 4. Those are what seal the aspirator nozzles to the carburetor body itself. If those gaskets become compromised, you could be dealing with a vacuum leak that is somewhat difficult to track down. The only other things to remove at this point is the power valve, which is here. But before we can get to it, we got to remove the other remaining thing, which is the cast iron base flange that goes between the carburetor itself and the engine. 3 Phillips screws. We'll start by removing this one. The other 2 you get from the other side of the carburetor, the top side. We can now remove the carburetor from the cast iron base flange. You'll notice we had to repair this one with a brazing job. These are your mixture screws. You can remove them. You probably should if you're going through a carburetor, reconditioning it for service. Pay attention to where they are when you take them out. So, should be doing this from memory, something like 4.5 turns or so, so I'll count every half turn. So that's about 4. About 4 turns on both our mixture screws. Really, the only other thing to remove at this point is the power valve, which we will now take out. We're now going to remove the power valve. Okay. Now with the power valve out, we have everything out of the carburetor. There is a circlip in the bottom of the accelerator pump well and a check ball. You really shouldn't need to mess with that unless you're having problems with your accelerator pump, and we'll go over how to test that here shortly. But for now, just leave that alone. If you do end up needing to go in there, a small pick or a very small flat blade screwdriver or a combination of both usually will get that circlip out of there. And then once you get the circlip out, very carefully turn the carburetor upside down. There's a check ball in there, very small. If you drop it and it goes rolling away, there's a good chance you'll never find it again. So be mindful of that when you remove the circlip. There's a couple things to point out now that we're at this stage. We had a phantom vacuum leak that plagued us for months, if not more than that. And after much consternation, we finally figured out of these 3 holes, 1, 2, 3, where the carburetor base itself mounts to the corresponding cast iron flange we just removed. This hole has the threads tapped in the carburetor body itself. We'll try to get the camera to focus on that, don't know if it will. But this one has been helicoiled, and the carburetor we were running prior to this one, we finally figured out that those threads were stripped, and it felt like that screw was tightening down, but in fact it wasn't. So there was a massive vacuum leak there. It was causing it to hiss off and on, and it had a horrible off-idle stumble. I don't care what anybody says, these carburetors are carburetors and they are old technology, but if you get these things set up right, they can and will perform very well for what they are. The other thing to mention at this point is when you get power valves for these things, these power valves, I think they're for a more modern carburetor than what these are. I think they're for probably a 4-barrel Holley, a more modern one. Not sure exactly what, but they do work with these old 94s. You need to figure out what size power valve you want. You'll have to do your own research on that, but there is a number on the side of the power valve, and we probably won't be able to get the camera to focus on it, but this one says 6.5. So that means at 6.5 inches of mercury vacuum, this power valve will open. And we'll go in how to test that here in just a second. But the main thing to look out for when you're putting power valves in these things is the fact that since these are power valves for a more modern carburetor, the gaskets that come with them, these are the proper gaskets. I don't know why we have 2 here, but they're doing their job, so we'll leave them there. The gaskets that come with these are for a more modern Holley carburetor, and if you lay the gasket out on this circular flange right here, this is the proper gasket. It matches up with the corresponding mating surface of the carburetor itself, like it should. So we went through our parts pile. Here is a comparison of power valve gaskets side by side. This bigger one in my right hand, this is the wrong one for a Holley 94. It's too big. You can see when you lay it out here, it just goes around the circumference, the perimeter rather. It goes around the perimeter of the flange it's supposed to be sealing on. So if you get a new power valve, chances are it's going to be the wrong big gasket. So look out for that. Just take a gasket that you think will fit and lay it on there. And if it looks like that, then you're good to go. So now we should talk about, if you're reconditioning one of these, chances are the thing needs to be cleaned very badly. So this isn't really hard. There's just some things to look out for. I've still got our 4 gaskets on here, and I'm leaving them there because, like I said, this carburetor, we just went through it. It's pretty clean. So once you get everything out of here, you should get some non-chlorinated brake parts cleaner and some compressed air, and that should be all you need to clean this out. So spray some brake cleaner and followed by compressed air until you are sure you have free-flowing air, clean free-flowing air coming through all of these, starting with pretty much every orifice you see. 1, 2, 3, 4, where all of the ends of the aspirator nozzles go. And then also right in here where your accelerator pump circuitry is. The holes, probably can't see them because of the angle and not being able to focus, but these holes through here where the jets go, make sure those blow free and clear. And then once you get that done, turn the carburetor over, and there's just a few areas to look out for here. Make sure these holes, these 3, 1, 2, 3, are free and clear of any obstructions. And then there are 2 holes in here. Right here is one, and then there's another one not quite 180 degrees out from it. That's part of your power valve circuitry. Make sure those aren't obstructed. You can use like a paper clip or whatever, but brake parts cleaner, compressed air, and paper clips. Personally, I like to use these, these are actually files for cleaning an acetylene torch, but they're all different sizes and they work great. These are always a good thing to have on hand anytime you're dealing with any carburetor. And then on the cast iron base flange, you have these 3 corresponding holes which match up to the 3 I pointed out on the base flange of the carburetor body itself, and then that one right there, and that's pretty much it on that. Make sure you get all the old gasket as much as you can off all these surfaces so that you don't have any vacuum leaks. And I have done before, I've taken a piece of fine sandpaper and laid on a piece of glass and basically lap these surfaces. Keep even pressure on it, move it around in different random directions. Don't ever keep moving in the same direction too much. And when you first start doing it, you'll see it'll start to be shiny in different spots, and that's where the high spots are, where it's hitting first. You'll keep doing that until you get the whole thing shiny and all of the dark areas are removed. That means you have true 100% contact at that point. You shouldn't need to do that, but it's something to keep in mind if you're battling vacuum leaks that you can't figure out. Most of these things are pretty worn out at this rate. There's quite a bit of slop in this throttle shaft, but it doesn't seem to matter too much. There's less movement whenever the plates are closed. When they're wide open, they move back and forth. So if you want to test a power valve, you need a tool, a holding fixture to do so. We got this, I think it's a Moroso piece, but basically the way it works is you unscrew this cap up here, screw your power valve into it, and then screw the cap back on, and then you need some way to pull a vacuum on it. So the power valve screws in the top of the testing tool, and then you just screw the cap back on it. So now we're going to use our Mighty Vac and pull a little bit of vacuum. I don't know if we'll be able to capture this on camera, but what you're looking for is for the power valve to open, which it will move up like I'm moving it with my thumb. And when you pull the inches of mercury of vacuum on this gauge that the power valve has stamped on the side that it's supposed to open at, roughly, it should open. So here, we'll open this one. That one's pretty much all open at about 5 pounds. Probably about six pounds or so. So I have no idea what power valve this is. It's just the one that was in there. So I figured we'd show you guys that. The next thing we're going to do is test the accelerator pump circuit and put this thing back together. You don't ever want to over tighten anything on these carburetors. Just snug is usually enough. So we've got our power valve in. Let's test our accelerator pump circuit now. So in order to make this easier to illustrate, I'm going to use automatic transmission fluid. I got a little ahead of myself. I started filling the float bowl with tranny fluid before I had the jets and plugs in, so I'll go ahead and put them back in now. Also, when you have these out, we won't be able to get the camera to focus on this, but there is a small orifice you can see, and when you get these out, hold them up to the light and make sure you can see daylight coming through that orifice. Real easy. Take a paper clip or torch files like I showed earlier, brake cleaner, compressed air. You want that thing to be completely unobstructed. We'll go ahead and put these jets back in now. So we got our jets back in. Now we're going to put our float bowl plugs back in. There's a little gasket on these plugs. Make sure that's there. Probably leak without them. Okay, now we can test our accelerator pump circuit. So I will go ahead and fill the float bowl with automatic transmission fluid, and I'm going to pour a little bit in the accelerator pump well here. There's already some bleeding over from the hole there. Try not to make a huge mess here. Just oil and a little bit of detergent, not going to hurt anything. Okay, so the first thing we want to test is we're going to drop the accelerator pump itself into the well, and we're going to push down on it, and we're going to look for, in our case we're using ATF, we're going to look for automatic transmission fluid to come up from this hole here where my finger is. This is the discharge port for the accelerator pump, which, if you recall, is where this piece was sitting. It was right there. We'll leave it off for now. So I'm going to drop the accelerator pump in, push down, and I should see fluid come up through it. Okay, we got fluid coming through it, so that's good. The next thing to check is we're going to pull this accelerator pump back out of the well. Not out all the way, but just pull it up. I'm going to put my finger over this hole, and I'm going to press down on it, on the accelerator pump. I'm pressing down on the accelerator pump while keeping the discharge nozzle up here, this hole, plugged with my finger. And what I'm looking for is resistance. I'm pushing down on it, but it's not moving down. So if I move my finger off of it, it should go down the rest of the way. And it does. And it pushes more fluid out. So what that means is that check ball that's in the bottom of the accelerator pump well here is doing its job, and it's keeping fuel from flowing back from the accelerator pump well into the float bowl. So the only other thing to check is basically to verify that again. I'm going to take our valve that drops in the accelerator pump discharge hole here, drop it in, and I'm going to do the same test as I just did, but I'm going to hold this down with this pivot pin out of the float. Press down on it. Again, there's resistance. If you see a lot of bubbles in the float bowl, that means that your fuel is going to be flowing back past that check ball in the accelerator pump well into the float bowl. You don't want that. So if that's happening, what you'll want to do is you'll take a brass punch, get all this stuff out of here, whatever you're testing it with, and gently seat that check ball in its corresponding hole in the bottom of the accelerator pump well. And you can also do the same on the valve that goes in this hole for the accelerator pump discharge itself. If you get a little bit of bubbles and fuel flowing back through here, that's not cause for concern. But if it's a whole lot, then that's an issue. So now that we've verified the accelerator pump circuit is working properly, we're going to remove this automatic transmission fluid and wipe out all the excess with a rag. Don't worry if there's a little bit of residue left in there. It won't hurt anything. Like I said, it's just oil with a little detergent. You'll want to get all of this out, obviously, so we're going to go ahead and do that now. Okay, so we got our automatic transmission fluid out of here, most of it. There's still a little bit of residue in there. Won't hurt a thing. So now we're going to put this thing back together. The next thing I'm going to put back on is the cast iron base. Go ahead and get it out of the way. There's the gasket, there it is. When you put this gasket on here, there's something else to keep in mind. The carburetor kits I've seen floating around, there should be 3 holes here, 2 here and 1 here, which match up with the carburetor itself. Pay attention to the gaskets that you're being given before you just slap it on and assume that the holes are there and they in fact line up. Because I have seen them.
We had to open those holes up a tad so they would match.
Yeah, these had to be opened up so that they would match. And since this screw hole was stripped out on this carburetor body, like the prior one we were running on the 32, someone has put a helicoil in here, so it should be good to go from here on out. I'm going to put these 3 screws in that hold the carburetor to the cast iron base. You might notice that on our carburetor we have this plug in here, and that's because we have ditched the problematic vacuum advanced distributor that was originally on this 8BA powering our 32, and we've gone to a modern electronic high energy ignition. No points, no vacuum advance, none of that. If you're using an old style leather accelerator pump, it would probably be prudent and wise to put a little bit of lubricant on it, just because it won't see lubricant ever again until you take it apart. It's going to be bathed in fuel all the time. So in our case, we were just testing the accelerator pump with automatic transmission fluid, so it's already pretty saturated, pretty oily. So I'm going to go ahead and drop it back in and then finagle the spring and the flat clip back on and try not to let it shoot off into oblivion with all this oil all over my fingers. Get it reconnected here. Okay, we got our accelerator pump spring and the little corresponding flat keeper bracket on top of it. We'll take this rod out here, and for our cars and our climate, we usually run this in the middle hole. One of these is richer and the other one is leaner on either end in terms of the amount of pump shot, accelerator pump you get. Can't remember which is which, but if you play around with it, you'll figure it out. We will go ahead and put our mixture screws back in, and I remember I pulled these out at approximately 4 screws a piece. Take a look at these. There's really nothing much to look out for here. Just make sure there's still a reasonably sharp point on the end and these springs are intact. Shouldn't have any issues there, but so I'm going to try to start these with the screw head, the opening where the screwdriver itself would go, flat like that, and I'm going to try to keep track of it and put it in at four turns approximately. So we got both our mixture screws back in at approximately 4 turns like they came out. Next thing to do, we're going to drop our valve in the accelerator pump circuit here, which goes underneath the accelerator pump discharge nozzle, which is this guy here. So we'll go ahead and drop this valve in here now. Pointy end goes down into the hole first. So we'll drop it in. There we go. The next piece to go in is the accelerator pump discharge nozzle itself. And also, this is another piece that you should be hitting with brake cleaner, compressed air, and something. A paper clip is probably too big, but if you have a set of torch files, there's probably one small enough that'll fit in there. But you'll have that main hole in the bottom, and then there's two really, really tiny ones there, right above my finger, and then a corresponding one over there. You'll know if this is working right because when you get it back on the car and hooked up with gas, when you get the float ball filled, every time you hit the accelerator pedal, you should see this thing squirt gas into the throttle bore. So we'll make sure our gasket is on here. Not going to come off. Little gasket there, it's good. Go ahead and drop this back in. Now we're going to put our accelerator pump, or I'm sorry, our aspirator nozzles back in. And again, this is something you should take apart and thoroughly clean if it is a carburetor that hasn't been reconditioned in a while. There's just, all you got to do is look around. You see there's several orifices there. Take this main screw out. Take this smaller screw out over here. Just anywhere you see a small orifice, you want to give the brake cleaner, compressed air, and paper clip or torch file treatment. Just make sure you get it all clean and clear. I've had these clog on me before. Not very often, it doesn't seem, but they will gunk up. Now we just put our retain plates and screws back in. It goes without saying, when you're working around one of these carburetors, there's a lot of little small parts, and you do not want something to fall down and get lost down here in the throttle bores, because if you put it on, if you bolt it onto your engine and you're not aware of that and you start cranking on it, you could end up sucking a piece of metal into your engine, which would obviously not be good. So pay special attention when you're working with all these little small parts that can run off. Those 4 gaskets that are underneath, one underneath each end of the aspirator nozzles here, that's going to be one of the next things we have to replace on this carburetor, because they're pretty squished, starting to show cracks. But for now, they're sealing, so we're going to leave them alone. But if this thing starts running weird in the future, that'll be one of the first things we will investigate. The carburetor kits, I feel like I should mention this. The carburetor kits that you get to service one of these, at least all the ones we seem to come across, they're made like a lot of carburetor kits, really, where they have enough soft parts, gaskets, and gaskets that they will rebuild a multiplicity of carburetors. So don't be surprised if you get a rebuild kit and you end up with a bunch of stuff in the kit that you don't use. That's pretty normal. Which also makes it more of a trick trying to determine what the proper little gaskets and O-rings and whatever else are that you need. So we got our aspirator nozzles secured with those 4 screws and those retainer plates. So we've almost got this thing back together at this rate. The only thing left to do is assemble the float and drop it in. When you have this thing apart and you're reconditioning an old carburetor, this is another area that should be given the brake cleaner, compressed air, and paper clip / torch file, otherwise ramrodding treatment. It's a little orifice in there. Don't know if we can get the camera to focus. There it is. You can kind of see it maybe. Well, you just want to be able to spray brake cleaner and followed by compressed air, and you should see it freely shoot out over here. First thing we're going to drop in is our valve here, which goes above the float. Drop it in just like the valve for the accelerator pump. It goes pointy end down relative to the way you're holding the piece you're working on. Next thing, we'll slide our float back in. You can reuse these old floats, but make sure that there's not a hole rusted in it, or corroded I should say, which would otherwise make it not work. Yeah, maybe shake it around. If you hear trash, you can hear this one doesn't make any noise. If you hear trash floating or rolling, rattling around in there, probably don't want to use that float. You just have to play around with that and see. So we're going to put our float in, and it's retained by putting this pin back in. Should just slide right in just like that. Sometimes you got to give it a little persuasion. There we go. Get it lined up just right. So now make sure that the float freely moves. It should, but it's easy enough to verify this now while it's apart. So now we're ready to put the gasket on, put this thing back together, and we're almost done. And this gasket it's going to work for now, but it's getting pretty used up too. Put our gasket on here, and then drop the top half onto the float bowl side, and put our last 5 screws in. This linkage over here, which this is for your choke up here, this is all pretty self-explanatory. Just make sure you get it together right. Like I said, it's pretty self-explanatory. We've actually been having pretty good luck with running both our 8BA flatheads, even through the cold Oklahoma winter months. Doesn't get that cold here, but cold enough. We've been running them without a choke at all, period. And usually don't even need to reach for the ether. They fire right off. As long as the thing's been started in the past few days and there is fuel in the float bowl, they usually start really easily. So there you have it. That's all there is to reconditioning and overhauling a Holley/Ford 94 carburetor. They're really pretty simple, and if you give them a little bit of attention, they should treat you well.